What is happening, guys? Welcome on back to the Daily Data live stream. Today we're going to be taking a look at Scikit Learn Pipelines. It is something that I realized I probably need to get a little bit better at, so I'm thinking that we can do it together and ideally see what we learn. I do know a little bit about it because I've used it in the past, but I realized that there is an absolute ton of stuff that we can actually get started and actually do with Scikit Learn Pipelines. It's like a whole wide world out there in terms of what is actually possible. Now, I don't know if you saw the short that I put out today, but the reason why Scikit Learn Pipelines are so powerful, particularly when it comes to deployment, is that you can actually save down the whole pipeline. So it means that you don't need to go and bring specific functions or bring specific classes along with your model when you actually go and deploy it, which as you go and progress in your data science career, you'll realize it's such a powerful skill. I'm sure that a ton of you have been hearing about ML ops or machine learning ops or that type of thing. That is where it truly comes into play. If you can package your model into the tightest possible little capsule that is possible, that's going to make just your life a ton easier. The IT guys are going to like working with you. The data engineering guys are going to be like, thank God this guy's got his stuff on lock. He knows how to do this. He knows how to get his models running and all nice and tidy. Anyway, Henry, why am I live so early? It's actually 5:35 p.m. right now. So I'm just finishing work or like day job and actually switching over to doing a bit of a live stream. Damn, 2:33. My guy, you're here early. How you doing, Kevin? How you doing, Aaron? How you doing, Kelly Malone? How you doing, Sarah? MD, how you doing? When is the new data science project videos are coming? I'm working on them. Got a bunch of stuff coming. Hey, Joao. Hey, Henry. Hey, Abdullah. How y'all doing? All right. Again, today's going to be pretty chill. Probably not as hardcore as what we did on the weekend. I don't know if you guys checked out the weekend video, but that was like my first major hardcore live stream where we did it for longer than sub hour. So who knows, we'll see how we go tonight. But we are going to be doing a little bit of pipeline stuff and at least doing a little bit of practice. So again, I'm not an expert in this by any means. I'm doing this to get a little bit better alongside you guys. But hold on, before we actually test this out, or before we actually get into pipelines, let's test down the breakdown board. If you've seen any of the tutorials, you know the breakdown board, you know it's important. Let's actually see if this is gonna work. Monday blues, go easy, man. Yeah, we're gonna take it pretty chilled out. I know the feeling. Ooh, okay. All right, we're working. All right, so this is the whiteboard on my, what is this, on my left? So this is, wait, on my right. Anyway, so ideally, if this is going to work, we should be able to draw on this bad boy. So imagine, let's actually draw this up. So pipelines. So imagine you've actually got your machine learning model, and let's say we're going to make it purple in this particular case. So imagine we've got our Scikit Learn model, and I'm just going to draw it as a cube, because whenever I think model, I think a cube. Let me bring the mic down a little bit so you can hear a little bit better. So let's say we've got our model there, right? Then what our Scikit Learn pipelines are going to allow us to do is not just have our, let's say, for example, our Scikit or our random forest classifier model in it, so RFC. It will allow us to have all those additional pre-processing steps. So if we actually draw this a little bit differently, right? Let me rub that out. I don't know why I put the model on the left-hand side. But what we would actually be doing, I feel like Khan Academy at the moment. What we'd actually be doing is, let's say we put our model over here. So this is our final package. Right, so what we can actually do is, let's say I'm going to draw our pipeline in yellow. We could actually stack a bunch of stuff together. So we could actually take our standard scalar, and then let's say we could actually go and then grab, I don't know, like a one hot encode. You probably will do this before or after. Anyway, one hot encoder. So you could actually stack these up together inside of this pipeline. That's what I'm actually going to show, and we'll actually experiment. And then we could actually do like a random forest classifier. Right, now the cool thing about this is that we could actually then, yeah, I know, Kevin, the breakdown board. The cool thing about this is that we could actually then grab all of these different components, and let's say, for example, we were going to use like a pickle or something to save down our model, or serialize it. So that's an important term, serialize, S-E-R-I-A-L-I-S-E, S-E, whatever. Anyway, so when we actually save this down, when we actually get our Scikit Learn model back, what you'll actually see is that it returns pipeline. And then inside of brackets, you're going to actually get all of these components inside of here, which is actually really, really cool. Now, there actually is one thing called a column transformer. So that's not going to work. I'm going to have to learn how to use this a little bit better. But there is also another transformer called a column transformer. And this actually allows you to do a bunch of additional, like you can get very selective with what types of transformations you do. And like you can say, for this column, I want you to do this. Because as of right now, if we went and used like standard scalar on a binary column, I actually have never dug into it, but I think that this would actually try to scale your one hot encoded columns, which is interesting because it's probably not the best way to actually handle that. So we're going to dig into this. Anyway, I figured I'd bring back the breakdown board. Let me know if you guys like it in the comments. But I do like it, so I want to try to bring it back because it helps me explain a little bit better. Okay. Alrighty, so now we've sort of taken a look at the game plan, or what we're going to take a look at. Let's actually do a little bit of coding. In the sign language model you have built, you used... in the sign language model you have built, you used pipelines too, right? Did I? Oh, yeah, I think I did for the action detection one. Let's actually go take a look at that. So I think if we go back to what we did for sign language, actually the action detection for sign language one, I believe we did use pipelines. Because this was based on landmark estimation. Wow, this was a while ago. When was this? 2021. Damn. Wait, that's over a year ago. Quite a fair few videos ago, just a tad. Wait, see, I don't... we did this with an LSTM model. I don't think we used pipelines for this one. I know we did use pipelines for one of them. I can't remember which. Breakdown board looks good. Love that you guys like him. Alrighty, pipelines. Let's, what do you guys prefer? Colab or me just doing it on my desktop? CD, what is a voice cloner? Yeah, CD 12. To activate our environment. So voice cloner, scripts, activate, Jupyter Lab. You used pipelines before, Tom? I would love to hear about your experience. Okay, so GLMs. Okay, all right, what are we doing? We are practicing pipelines today. So I've got this CSV. This is just the spaceship Titanic one that we... Actually, you know what? I'm tired of looking at that one. Let's go get a different one. Let's go find a... Let's just go get one of the getting started ones. What else do we got? I'm something of a painter myself. That's again... How do we filter on tabular? Wow, I've got to get better on Kaggle. Hey, house prices. This is probably... Oh yeah, this is good. Yeah, let's use this. All right. Pipeline prevents from data leakage. Yay. Guys, any thoughts? Colab? Normal Jupyter? Don't care? Let me know. All right, we're going to start with... Okay, nobody... All right, well, let's just do it in here. So I am going to create a new Jupyter notebook, and I don't believe I've actually gone and set up Kaggle on this computer. So this could be actually... Let's go do it with Colab. And I need to grab my... Hi Ram, how you doing? What am I doing? I'm blanking out here. Create new API token. So we need our API token. We are going to create a new notebook. And we are going to work with some pipelines. And then let's just rename our Kaggle file. I'm going to call it just kaggle.json. Bring it to my desktop. And I've already got one there, but I ran and created a new one, which is going to cause a problemos. Let's grab that. Okay, so let's upload that. And then, all right, let's go through our Kaggle walkthrough again. So first up, let's create a text box. So authenticate to Kaggle. And all right, memory path. Again, this is how I'm been practicing my memory path, guys. All right, so first thing we need to make the directory, and it's going to be squiggly line /.kaggle. So that's going to be our first command. And then our second command, we want to copy this kaggle.json. How does that look over there? Yeah, we want to copy kaggle.json into the .kaggle folder. So if I'd actually type in, what is it, .ls, we should be able to see the folders. No, we don't see folders. Sample data, cd squiggly /line end. Okay, God, my bash is a shocking. My mate would absolutely smash me. All right, so there's clearly squiggly line. Okay, so that is... Oh, it's because it's a dot. It's going to be hidden. Okay, that's fine. I've got to learn how to actually render that command. Anyway, what we want to do is copy our kaggle.json file into that folder. So copy kaggle.json into squiggly line or tilde /kaggle.json. And then we want to change permissions, chmod 600 tilde / I should really call it tilde permanently, right? I mean, it's a squiggly line anyway. Right, so that's going to change our permissions. We should then be able to authenticate if Kaggle is already installed, which we can check. So pip list. Is it here? HIJK. Kaggle's already there. We don't need to install it. Beautiful. Okay, so then we can run !Kaggle competitions download -c, and then where was our competition that we wanted? We were in competitions. Getting started. What was it? The house prices one that we wanted. Advanced regression techniques. All right, so we can copy this. So we've already set up the Kaggle API. Can you see that? Or might need to move that chat. Hey. -c. I've spelled download wrong. Download. All right, we're good. Okay, so we should have our data somewhere over here. We do. Beautiful. Now what we need to do is unzip it. So unzip, and it will be called, we can just copy this. All right, cool. So we've got all of our data there. So we're going to play around with train, but you can see that we've got all of our data. So we've got test.csv, train.csv, sample_submissions.csv, data description.txt. I didn't know they came with data descriptions. That's sick. What's in here? Oh, it's beautiful. I love it. I like it a lot. I like it. Picasso. All right, cool. So we are good over there. We've authenticated. We've got some data. Let's mess around now. So pipeline practice. Okay, so let's actually bring up documentation because this is always a good thing to do. But just for example, let me actually show you how I do this traditionally. So let's say we just want it to be like really sketchy and make, all right, let's load in our data frame, but let's say we want it to be really sketchy and just build a super fast pipeline to make a bunch of random predictions. This is me really going a low quality type prediction. Let me turn off this camera to make sure that doesn't die. So what would we do? So we'd load up our data frame. So df equals pd.read CSV, and then we grab train.csv, which should load up this. We haven't loaded in pandas, so we need to import pandas as pd. And then if we run that, all right, now let's make like a machine learning model in like a few minutes, so, or like less. So if I go df.head, right, so there's a whole bunch of nans. Okay, so beautiful. And we've got our sales price over here, which is that column. I wish there wasn't so many columns with missing values. Anyway, let's just grab a couple of columns as our feature columns then. So we're going to go df. And the reason that I'm doing this is just to show you how I currently use it, because I want to improve in it, and hopefully you guys learn a little bit as well. So what I would typically do is go from sklearn.pipelines, import make pipelines. This is from my memory path. And then from, let's say I wanted to use models, sklearn.ensemble, import random forest regressor. And then I would also bring in transformer steps. So from sklearn.preprocessing, import standard scalar. This is also pipeline, not pipelines. From sklearn.pipeline, import make. Should be make pipelines. Make pipeline. My bad, not pipelines. Okay, cool. So then let's make a really rough and ready ML model. So we know that we've got our target column, which is going to be the house price, right? So if we go and take a look, does it say it in our data description? Go and read this. Okay, so okay, we're not getting, so df.columns. Okay, so sales price, I'm pretty sure, is going to be our target. Oh, this is alphabetical. That's Is it all right, so it's right at the top. Sales price. So you can see that there. So sales price, the property sales price in dollars. This is the target variable that you're trying to predict. Okay, so let's make a rough and ready machine learning model, which will do that. This is not best practice in terms of making this model, but I want to show you how I use it. If you've seen the end-to-end machine learning live stream that we did on Saturday, this is going to be very similar. Right. All right. So let's grab a bunch of feature columns. So df. So we're going to say x equals df, and we can grab a bunch of columns. What's a set of columns that doesn't have a ton of missing values? So let's grab that. And maybe that. And this and this. You guys see that? All right, so basically I'm just grabbing a bunch of columns that I want to use. And we are going to limit our data set to only those. Probably didn't need that many. How's your Monday going so far, guys? Yeah, that description, who said that? Christoph. Yeah, that description is like really, I didn't realize they came with a data description. Okay, that should be okay. We've got a bunch of columns. What have I done? Utilities, misc val. Did I copy those together? My guess is I did. Yep. This should have. Okay, so we've got our X value, then our Y value is just going to be sales price, df dot sale price. Okay, now a little bit of rough and ready transformation. So let's drop any missing values, drop NA, and then we are going to one hot encode this bad boy over here, just using pd.getDummies, which is, it's very bit fluid when you use pd.getDummies, which is why I'm like, there's better ways to do this type of stuff. So let's just wrap this up here. So pd.getDummies, which will one hot encode the whole bad boy. So we need to drop NA over here as well. Actually, we should do this. df equals abt equals df.drop NA. No, because that's going to drop the missing value. So we want to grab, let's grab this and let's throw sale price into there, sale price. So we're going to call this select data frame. So it's just selected columns that we're going to be using. And then that will give us our sales price and all of our different feature columns. That looks somewhat okay. Boom. Okay, no issues there. And then what we'll do is we'll append drop NA to the end of it, just so you can see that there. And then we will then go and say select df, and we want to drop our sales price column because we don't want that in our feature columns. So sales price, and then I'm going to pass through access equals 1. We're probably going to do pipelines over a couple of nights because there's a ton of stuff I want to get through, but I've been exploring today. Select df.drop, that's going to drop this column. We're saying access equals 1 because we want to drop a column, not a row. That should work. And then y will equal select underscore df and just give me the sale price. The sale price? Or, yeah, it is. Okay, beautiful. All right. So this is where pipelines come in, right? Let's clean this up. So what are we doing? Do we need this? Let's leave that there for now. Okay, so let's add some comments. So what we've so far done is we've gone and said, give me only certain columns so I don't need to deal with nans for now. You know, it's funny. I was watching the Formula One this morning, the replay, and there was actually a shot where they're actually using computer vision to track the car. And typically they actually have I think they might have a classifier that actually gives the name of the driver underneath the what is it, the number or the car. Like, so it's basically the car. Wait, is it the car? It's a picture or a tracking value to say that this is the driver. So in this case, it was tracking Charles Leclerc. And then underneath, it actually had, I think it was either to show the delta between the current car and the car in front of it. And it actually said NAN, like for a brief moment. So clearly the developers have got a little bit of work to do. This is the F1 as well, guys. If you're an F1 software developer right here, you need a hand, hit me up, guys. Only certain columns I don't need to deal with nans for now. And then, all right, so that's going to give us, so let's quickly take a look at our, what do we need? MB. I've minimized everything now. What do we want to do? So x.head. So let's just double check we've got our features that we want. Okay, we shouldn't have any missing values and it's been one hot encoded. All right, so how I would use a pipeline typically. So I would go, we don't want this to be a text column. So I'm having a complete mind blank adding. So how I would typically use it is I'd say pipeline equals make underscore pipeline, and then I would go, all right, throw in a standard scalar, and then throw in the random forest classifier. Wait, we're using random forest regressor because it's a regression problem. Bring this back up here. And then what I would do is that you can literally just go pipeline.fit. And then pass through X, Y, and then whatever other columns you want. I'd normally pass it through like a grid search CV. That's literally our model now fit, right? So I could then go pipeline.predict and pass through X, which is not right, but like that's how you'd effectively be able to do it. And that's making predictions now. So that is the beauty of pipelines, because what you can see now is that over here, I've actually got the different steps that I would go and use to apply or to build up a machine learning model. But there's so much more to this. As like I was reading over the weekend, and there's Aurélie Géron's book. He actually talks about this and like the column transformer, and there's a whole bunch of additional stuff, and it's wild. But the beauty of it, which I'm trying to explain to people, but maybe I'm not articulating it well, is that you can then go and save a pipeline, save the pipeline. You can actually then go, so let's import pickle. And then I can go with open, let's say pipeline model.pkl. And then we're going to write binary as F. We can then go pickle.dump that specific model. So I can go dump that pipeline as F. I've spelled pickle wrong. Right, so you can see that I've got pipeline model here. So that means that when I reload it, I'm actually going to have the standard scalar. So standard scalar is not a big, it's not like a crazy transformation, right? But there's a ton of additional transformers that you can use with the Scikit Learn Pipeline API. So I can then go with open pipeline model.pkl and watch this magic. I think it's fascinating. As F, and then I can go reloaded model equals pipeline, pickle dot load F, which should reload the pipeline. So then if I type in reloaded model, boom. So we've now gone and loaded up the entire pipeline. Now there are other ways. So you saw that I went and defined the pipeline as literally just the steps. So this is the nice bit about making the pipeline. So I can type make pipeline, and then I get standard scalar and random forest regressor. Now I can actually go and extract certain steps. So when you typically want to go and do like get feature importance values or get coefficients, if you're using linear models, you can actually go into this value over here, which is, I think, something that not a lot of people teach, because it's like, oh, that it's done and dusted. But you can go reloaded underscore model, and I think you can get type in like get pipeline steps. It's dot something. Name steps. So there's name steps, but I don't think that's what I was looking for. So this gives you the dictionary. So then can I go random forest regressor? Right, so then I can get that regressor, and then I can type in, I can access everything that I would typically go through. It's not name steps. That's not the right thing. Get feature params, feature names, classes. I think it's steps. Okay, there. So I can go steps, and then I can go give me the second step, which is index 1, which will give me my transformer. There you go. So then I can grab whatever I need out of this. So we can grab the second value out of that tuple, which should be our random forest regressor, and then all the values available out of our random forest regressor. I think. Can we not use predict here? There you go. So that's returning fit values, but that effectively shows you what you can actually do with these pipelines. There's actually a ton of stuff. Now let's jump into that. Before we do that, let's quickly jump back on over to the chat. That's at least the beginnings of what I want to go through. Again, this is only meant to be 5 lines of code a day, but maybe we'll do a little bit more. We'll see. Alrighty, to the chat. And I've turned this camera off. Let's turn it back on. Last time it died midway through the stream. Okay. Let's have a look. Where did we end up? All right, so we got collab. Anybody else with collab? Please make a video about GLMs. Sure, why not? Hey, Akash. Hey, Lakshman. How you doing? End-to-end machine learning project. So many people have asked me about this, but guys, have you been to the YouTube channel? There are so many end-to-end machine learning projects on there. If you actually go to videos, right? All right, I'm gonna drop this. So if you actually go to here, like there's this reinforcement learning for gaming. There's like, I think there's 4 or 5 different machine learning projects in there. And then if you actually go to over here, so if you actually go to this playlist, deep learning projects with Python and Keras, it's there for you guys. I'm gonna eventually turn this into one big video, but these are all like unique data science projects. So building an image classifier, deep face detection, comment toxicity, building GANs, building iris detection, and building an audio classifier. There's a ton in there. If you guys need any inspiration at all, please do go check that out, because there's a ton of end-to-end machine learning projects. They are truly end-to-end, because it's about, oh wait, I'm not sharing my screen. What the hell am I doing? All right, you guys probably missed all of that. So if you actually go to the channel, right? Let me zoom out of this. If you go to the channel and go to playlists, there's a playlist here that I've sneakily called Deep Learning Projects with Python and Keras. There are a ton of deep learning projects on there. They're all very much end-to-end. I go through a ton of stuff. This is a monster one where I tried to recreate a machine learning or a deep learning model from a research paper. So I think people were asking about that a while ago, but there are a ton of deep learning / machine learning projects inside of this playlist. If you actually open it up, a lot of these are unique as well. So we go through deep face detection, we go through comment toxicity, we go through GANs, iris tracking. There's 3 more that I've got left in this series. So before I make a big video of it, because I want it to be 10 videos total, but just know that there's a ton of end-to-end ML projects in there if ever you guys want to check them out, but please do. I'll really appreciate it. I like that I went and did all of that first time and I wasn't even sharing the screen. Alrighty. Yeah, there's a ton of end-to-end stuff. Hey Nick, I think it would be better if I move to the chat to the left because data won't change much. Yeah. What do you reckon? Like move it, like I was actually thinking just, yeah, I don't know. Maybe move it to the left. I'll sort that out tomorrow. I've worked on that data set. It is a sick data set collected from 2 climatically contrasting regions in southwestern Germany for the period of 2009 to 18. Fascinating. Monday is okay. Slow Monday. I got a model which is showing better accuracy when RF bootstrap equals false. I'm confused. Part of the game. I think everyone's always confused with machine learning, let's be honest. What else we got? It's an awesome Monday of regression. Is it not better to use pd.getDummies data drop first equals true? What does drop first equals true do? I haven't actually ever used that command. Anyway, we'll check that out. Again, I'm learning. But I've heard using get dummies is not good practice. I mean, who says what good practice is or not? But like, I typically don't like to use that because you don't have as much control over the one-hot encoding, which is fine when you're training, but then when you have to go and make predictions on real data, you need to restructure your pre-processing pipeline to actually make a prediction. So that's just something to keep in mind. Or maybe try to find the F1 GitHub page and submit an issue for that now. Why? All right. Why? I'm going to talk about this. So why make pipeline and not just pipeline? I need to know the difference. I'm actually going to show that. Can you do a complete deep learning project from scratch? Guys, Ishan. There's the playlist. You got to check it out. I'm using a random forest classifier for sign language detection. One big video, it's coming. All right, let's go dig into that. I'm always going to be doing more tutorials on machine learning and deep learning and whatnot. So if there's more, like, actually, this is a good question. In terms of end-to-end, what do you truly consider end-to-end? Is there stuff that I'm not showing that you guys need to or want to learn about? Let me know, because a lot of the ones on there, I'd personally consider them end-to-end. Like if I had someone that I was interviewing and they showed me it to that level, I'd be like, that's end-to-end. That's good. You've done stuff. You've gone and done an implementation to a certain extent. I think it's good. Okay, difference between pipeline and make pipeline. So let's take a look. So if we actually go and import pipeline up here. So I use make pipeline, which automatically names my steps, right? So you can see that the step is named standard scaler and random forest regressor. If I'm going to go and build a pipeline manually, I can type in let's say it's not manual. I don't want to class it as manual because it's not. What are we saying? I'm having a mental break. Manual, let's just call it, let's not call it manual pipeline. Let's call it non-make custom pipeline. Wow, I like that. I'm having a mental dilemma over what to name the pipeline. All right, so using the pipeline class. So custom pipeline, we then call it pipeline. And then I believe, so previously I didn't have to name the steps. So here I now need to name scaling and then pass through what I want to do for scaling. So which would be standard scaler. And then the next thing that I'd have to go and pass through is the next step. So I'd go RF model and then pass through my random forest classifier or regressor. Takes 2 positional arguments. Maybe this has got to be inside of an array or something. There you go. So you can see there that there's just a little bit more work. So that's what happens when you're using the pipeline, right? This is with the pipeline class. And then this is with the make pipeline class. So let's take a look at the difference. So this is make pipeline model. So it would be make underscore pipeline. And then I literally only need to type in standard. I'm just making sure I don't cut it off on that side. Standard scaler and then random forest regressor. So it does pretty much the same thing, right? The only thing is that I can change what each one of these steps are called. So if we take a look at custom pipeline now, that's what my custom pipeline looks like. And look at the names. This is the important thing. So this first step is named scaling. The second one is called RF model. If we go to make pipeline, it automatically names the steps for you. So you can see it says standard scaler and then random forest regressor. So you don't need to go and name those steps, which is why I typically use make pipeline. But again, to each their own. There's a ton of additional stuff. What else are we taking a look at? All right, let's go and dig in. I'm probably only going to do like 5 more minutes, guys. I'm starving. Pipelines, Scikit Learn. But if you guys want to do more on pipelines, you let me know. So, okay, so like say I wanted to, the thing that I'm most interested in using or learning to use is the column transformer. Column transformer, here we go, with mixed types. So this is really, really cool. I was reading about this inside of Aurélie Géron's book. This is me trying to do a fake French accent. It sucks. But you can see here that you can actually stack a bunch of these pipelines together, which I think is super sick. So let's read into this. So the numeric features. So we create a numeric transformer. And then we create a categorical transformer. And then with our column transformer, we specify what we want to apply to what. Do you see that? How sick is that? All right, let's try doing this. I'm going to throw that up there, and let's make this a little bit tad smaller. So we are going to look at column transformers. Okay, so what do we need to import first? So I think we need sklearn.compose. So from sklearn.compose, can you see that as a bit small? There we go, it's a bit better. From sklearn.compose, import column transformer. And then how do we structure this? So we ideally would want to specify what the numeric features are. The first handle numeric features. I actually did, like I went and studied this a while ago and threw it in the course, but I had just, I want to practice and get a ton better at it. Categorical features. Okay. I've got a wedding this weekend, so I'm just doing as many videos as I can until my best mate's wedding, and then we're going to really get back into it. Hardcore. Okay, so we've got column transformer. What's another preproc step that we might need? Like one hot encoder from sklearn, a preprocessing import one hot encoder. And then we would ideally want to identify what our numeric features are versus what are our categorical features. So if I said select df dot, what is it? I think you can type in select d types and then object. All right, and then I can grab the columns. All right, so that gives me the columns that are going to be categorical, so I can actually grab that. And then I can say, so these are going to be categorical features. Equals that. You know what? Let's just put this in another tab. We don't need to see it side by side. So those are going to be my categorical features. And then I can go numeric features equals select df.select d types. Can I type in exclude here? Yeah. Object dot columns. Numeric features. Beautiful. Look at that. All right, cool. Wait, hold on. Why does that say D type object? We celebrated way too soon, guys. Numeric features. Shouldn't be a slash there. Cool, that looks okay. And then categorical features. Like, I think it's so powerful. If you can like have that level of a pipeline. All right, see, that looks good. All right, then what do we need to do? So then I believe we define what our pipeline is. So let's say we just wanted to scale our numeric features. We might apply a standard scaler. So it would be, let's create a numeric pipeline equals pipeline. And then we would pass through our different steps. So we'd pass through, I don't know, standard scaler. Let's just create a simple one to get it working. Standard scaler, which should just scale our numbers using z-scoring. And then if we were to go and use it on categorical features, we would need a categorical pipeline. So categorical pipeline, and then we would say pipeline, and then create, let's say we wanted to one hot encode our categorical features. We would then create a step. I know I'm just doing a single step, but it's at least applying that preproc. We'll combine it. What are we doing? One hot, and then we would pass through our one hot encoder here. Boom. And then I believe this is where the magic happens. So we can then combine them. So let's take a look at the column transformer. Nope, I don't. My question mark. Let's bring up Doco. Okay, what do we need to do? How do we use this? Okay, so column transformer. So we then... But this is saying for normalizer, and then, but what is it doing it on? Is that just specifying the columns there? That Docker is not great. Okay, so we are saying that these are our numeric features. We've gone and set up our pipeline similarly in a similar fashion. We've gone and set up our category. All right, so then this is the interesting bit. So then we go and structure our column transformer like so. So this is naming it. This is saying, okay, all right, I got it. So we would then go and say, so this is our transformer, not to be confused with transformer deep learning architectures. Then we would say transformers. Here we go. We could probably just pass through what's called a list, right? And then we would go step one, or for this particular part of these particular columns, we'd say this is for our numeric transformers. Pre-processing. We would then go and say that we want to use our numeric pipeline. Numeric features. So then we want to specify that. Okay, I think I'm getting the hang of this. So we'd go and specify what columns we wanted. So what we want this step to be called, what we want to do to it, and then what columns it's going to apply to. Then we'd go and specify the same for our categorical pipeline. So this would be categorical pre-processing. We'd then go and use our categorical pipeline. And then we'd go and apply it on categorical features. Beautiful. That, what did we import? We don't need that. If we go and take a look at our transformer, that is so cool. So you can see that we've now got a, oh, this is awesome, guys. This is exactly what I wanted to get to tonight, because this is really, really, really powerful. So we've got our numeric pre-processing step and the actual pipeline that we're going to use for that. And you can actually even then go and create custom transformers if you need to do a specific type of pre-processing. I'm going to use this so much more now. And then we specify the object or the columns that we're actually going to use it on. And then we're doing categorical pre-processing and then the columns that we're going to use it on. Ah, this is good. I like it. I like it a lot. I like it. Picasso. All right, cool. So that's our transformer. And then we'd actually go and create our machine learning pipeline, which would be, I think, pipeline. And then we would go create our steps. So first up, we'd pre-process. So complete, so all column, let's call it all column pre-processing. And then we'd pass through this transformer. Because again, you can stack them. Like you can go and create a ton of different pipelines and then stack them all together. And then we'd go and create, apply, or pass through our random forest classifier. So random forest classifier. And then pass through our model. I'm just going to bring this over to here so you guys can see. That doesn't help at all. Really got to work out where to put that chat. Random forest classifier. I think that's looking good. Regressor. Forest. Boom, boom. Oh my gosh, that worked. So now if we take a look at the pipeline, so this is obviously a way more detailed one. Take a look at that. So we've now got our column transformer pipeline, which is all of this. And then we've got our machine. So you can do a ton of stuff and keep it really nice and tight now. I'm going to have to make a memory path of this. Is that something you'd like to see me actually doing a memory path for something like this? I actually teach you, or you actually see me doing it live? yeah, I really do like these pipelines. I've been meaning to I've been very much focused on just TensorFlow, but I'm keen to get back into Scikit-Learn. All right, could we then, I don't know what I've actually gotten done with my data, but could we then go and just pass through select df to that? Dot fit. We would say we need to pass through x and y, don't we? So select df, and then but this doesn't have any, it would still have nulls. Select df. Hold on, wait, would it have nulls? Let's go back. What did we actually, wow, we wrote a ton of code. So much for 5 lines of code a day, guys. All right, so where did we, all right, we've already dropped NA, so we're okay. We don't need to handle that. So this should already handle our categorical columns then. All right, so let's do some magic. So if I go select, so x equals select df and then drop transported. Hold up. We need to remove. So from our numeric features, we don't want what's it called? We don't want to have the target column. So if I said select df.drop transported. No, it's not transported, it's sale price. I'm getting confused with this should be axis equals 1, boom. Because we don't want our target column to be as part of our transformers, because maybe I think it'll throw issues. Numeric features. Yeah, cool. All right, that's better. So now if I run that. All right, so x will be select df.drop transported, comma, axis equals 1, and then y will equals select df dot, we just want sales price. Sale price. Yeah, I think that looks okay. Transported not found. Sale price. I'm still stuck on the spaceship Titanic model that we did on the weekend. If I do that, we get errors. Okay, hold on. A given column is not a column of the data frame. Sales price, where is it throwing an error? Knew it. I knew we were going to get errors. All right, so where is that column now stored? Categorical features. Is it in here? It's not in here. Numeric features. Given column is not a column of the data frame, but we have stripped it out. All right, let's think this through. So select df.drop. The numeric features, so I've run that. Anyway, I'm getting preoccupied, but we've sort of at least got the pipeline set up. Clearly, I just haven't pre-processed correctly. So numeric features, categorical features. We might finish this tomorrow. What's the time? 6:27. ML pipeline.fit. Show me my transformer again. You need all columns inside of your transformer? You shouldn't. Wait, so MS subclass, lot frontage, lot area, misval, MS zoning. So if I go and run bang, 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 bang. Okay, no, that worked. Magic, guys. How awesome is that? So then again, the beauty of this is that I can then go ML pipeline. I know not perfect, predict, pass through X, we're making predictions after going through that pre-processing pipeline. That is so awesome. How good is that? And again, the beauty of it, I know I'm getting super hyped up, but I can then go with open column transformer pipe model dot pickle, and then go write binary as f, and then pickle dot dump ml pipeline f. Beautiful. So we can then go and stack in like custom transformers, a ton of stuff into here. We can get really fine-grained with how we actually manage this. Because the beauty is then I could go and read it back in. So I can run reloaded ml pipeline equals pickle.load. Which means that we now have all of those steps safely stored away. How good is that? Oh my God, that makes me so happy that we got through that and that we got it working successfully. But that is so, so powerful, guys. Don't underestimate what we went through tonight, because there is a ton of stuff that's actually possible with these transformers. Do you guys want me to share the notebook? Yeah, let's share it. Column transformer practice. I'll download this for you guys and I will share it. Let's go save it on GitHub. Create a new, what is it? Column transformer practice. Let's see. Let's try saving a copy in GitHub again. It didn't work last time. We need to create. Oh, we need to create a branch. I got to work out how to do that. Download Jupyter Notebook. I'm gonna upload this for you guys, and then we'll answer some questions and we'll wrap it up. Probably clean this up, but at least you guys get to see it raw. So, and I did not wait for it to upload. Let's go back. Let's upload. Oh yeah, here you go, guys. If you guys want to play around with that, link is in the chat. You can play with that. Hopefully you guys have enjoyed this. We've gone through a ton of stuff. So we took a look at how to authenticate to Kaggle. I showed you some random, some of my basic pipelines. And we also took a look at column transformers, which I think is going to be super useful if we're really going to hit the ground running on some Kaggle comps coming up, because that's what I'm planning on doing. I really want to go start smashing out some Kaggle competitions and giving it a crack so we can ideally get a little bit more competitive. Okay, cool. So we have gone through, let's go through the chat, see if there's any other questions that you guys had. Hopefully you guys have enjoyed this one. Alrighty, can we use reinforcement learning for regression problems? Typically you wouldn't need to, like you really want to be using them on like unknown environment type problems. Is data analysis and prediction using AI the same as data analysis and using machine learning? Like neural networks are a great capability, but just treat them as, well, if you're using it on tabular data, very similar. It's just you're using a different type of algorithm. Maru, thanks. You made my night. You said you are the best. Hey, Nick, can we use a user-defined function in the pipeline? Yes. So you can actually use the transformer mix-in to do that. It's something that I want to do in maybe like we'll do it after tomorrow's live stream. But Nick, thank you for the live. Glad you loved it. For me, end-to-end is right from importing a data set using SQL to deploying it on fly. Well, that's one type of end-to-end model. I mean, there's a ton, but yeah, Would like to love an advanced video on pipelines, maybe redo the spaceship Titanic using a single pipeline. I would actually really like to do that. I think I actually really wanted to, I don't want to go back to the spaceship Titanic video again unless we wanted to try to improve performance, but I definitely want to do an entire video purely on pipelines. Memory path for the win. Okay, all right, maybe I'll do it. We might do it on Wednesday. We'll see. Make the camera in the top corner. I mean, you let me know, guys. I'll put up a poll if you think top corner is better. I think it actually might be top better now. The top might actually be better because then it's not down the bottom. Actually, that's not a bad idea. Solid suggestion. Who said that? Rowaid. Thanks, man. Abdullah, I'm a complete beginner and I found your videos quite helpful. Can you please do a live session on data analysis as well as data predictions? Sure. Thanks for uploading. I'm trying to share a bunch of stuff. You also have function transformer for UDF, Scikit Learn function. There's so much stuff. Yeah. Alrighty, guys. I think I'm going to wrap it up now. How important is it to know about model deployment in order to secure a data scientist role? That's a really great question. It is very important, and I think it's something that you should take on as paramount in terms of a periphery skill set. So just knowing how to build models is great, but knowing how to do it end to end is way better. But yeah, we're going to probably keep on going with transformers and the pipelines on Wednesday. Hopefully, if you guys get some ideas between now and then, let me know in the comments on the live stream because this is going to go up straight after. Hopefully you guys have enjoyed it. Thanks again for tuning, guys. Love you all. Peace. I'll see you in the next one tomorrow. Peace. Bye.